Welcome. So hopefully this video will explain the four different types of transformations that we're looking at in this class. Namely, when I take a value of k, and k can be any number. K can be a positive number, negative number, it can be a fraction, it can be something between 0 and 1, it can really be anything you want. And so k here, notice f of x plus k is outside of the parent function. K times the parent function f of x, it's multiplied in front. F of k times x, notice this k is multiplied inside of the parent function. It's inside, it's where the x is. And then f of x plus k, and this one's also inside, but it's being added inside. So the difference between f of k times x and f of x plus k is that this one is multiplication, and the bottom one here is addition. So if we're really looking at these functions, I want to highlight some of the important things. So again, this is when I'm adding on the outside, and we're thinking about positive and negative k. So when k is a positive number, this is a vertical shift. So it's I'll write the formal name, vertical shift, which basically means it moves up. It's a vertical shift up. And so here's some examples. We could have x squared as the parent function plus 2. And that would move the parent function of x up 2 units. And we could have the absolute value of x plus 2, and that would move the absolute value function of x up 2. Or we could have like the square root of x, and then notice it's outside of the radical, plus 2. And those are all examples of vertical shifts up. So those take the parent functions and put them out. If you'd like to see them, I recommend using a program like Desmos to graph these to see what they look like. That's for every parent function in this whole unit. And that's when k is a positive number. So here I'm using positive 2, positive 2, positive 2. We could have x be a negative, which would be a vertical shift down. And if k is negative, it's a vertical shift down. And that just moves it down. So we could have x squared minus 2, or the absolute value of x minus 2, or the square root of x minus 2. Notice these are all outside of these parent functions. When I have x plus k, it's on the inside. Notice that plus k is inside this parent function. It's not outside like the other one. And rewind just a moment to see the difference between these two types of functions. But when k is a positive number, when it's inside, it's horizontal. It's a horizontal shift. And when k is a positive number, it actually moves left. And I'm going to make this capital, and I'm going to underline it, and maybe I'll even go in and I will use a highlighter to highlight the importance that we are moving it to the left. And some examples of this would be x plus 2 quantity squared, so that's the parent function is an x squared function, or we could have the absolute value of x plus 2, or we could have the square root of x plus 2. Notice that it's inside the parent function, it's a positive number. For negative k, we could also do this. It's a horizontal shift to the right. So I'll write that down. It's a horizontal shift right. And I will again highlight this just to emphasize the importance that it is a horizontal shift to the right. And we would do, let's say, x minus 2 squared, or the absolute value of x minus 2. And again, notice these are all inside of the parent function. When k is multiplied on the outside, it does some pretty interesting things. And when k is bigger than 1, and I'll write that in there because I think it's an important thing, k is bigger than 1. I think it's important that you know what the symbols mean. For positive k bigger than 1, this thing is actually a vertical stretch, which means it moves up and down, but it essentially makes it more skinny. That's the more skinny or more narrow. A lot of people use that term. And so this would be something like k, or like 10 times x squared, or 3 times the absolute value of x. So it's all within the relationship of what the parent function is, 2 times the square root of x. And these are just multiplied by the parent function. So to really understand what this next thing means, we really have to break it down into 2 sections. So for k is bigger than 0, but less than 1. So essentially what that means is it's not equal to 0 or 1, but it's between those two. So usually this means it's a decimal value of some sort. So when k is between 0 and 1, it is a vertical compression, and oftentimes this makes it more fat or more wide. More wide. I think that's the politically correct way to say it. More wide. Sorry. Or fatter. And we can give you some examples of this. So this would be like 0.5 times x squared. I'm just making the numbers up that are in front. 1/3 times the absolute value of x, or 0.25 times the square root of x. And notice that these numbers in front here are all less than 1, but bigger than 0. They're positive numbers that are less than 1. And for negative values, I'm going to move this. Hopefully I can move. There we go. For negative values of k, we essentially, it's a vertical reflection. So a vertical reflection, or it's over the x-axis. Over the x-axis. And it just means that for any of these other functions, if there's ever a negative in front, these two things still apply, but it would be reflected over the x-axis. So for example, if I were doing something along the lines of like negative 10x squared, it would make it really skinny and it would reflect it over. Or if I was doing like 0.5 x squared, this would be really fat. Oops, excuse me, negative in front. It would be really fat and reflected over the x-axis. And last but not least, when k is multiplied inside, this has a very similar relationship to what happens when k is multiplied in front, but this time everything happens with respect horizontally. So for positive k, when k is bigger than 1, it is a it's a horizontal compression. So it makes it skinny. It makes it skinnier. And notice this has kind of the opposite effect that the positive k has when it's multiplied on the outside. So it's a horizontal compression. And some examples of this might be like 3x squared, or the absolute value of 2x, or the square root of 25x, or something along those lines. This takes the parent function and makes it a horizontal compression, or it makes it skinnier. when k is between 0 and 1, it does just the opposite. It's a horizontal stretch. Which makes it generally more fat. And so some examples of this are, 0.2 x squared. And again, I'm making these numbers up that are happening in front, or 1/2 of the absolute value of 1/2 of x, or something like that. And again, this is really the most interesting piece. When k is negative, and when k is negative, it actually reflects over the y-axis. So it's a horizontal reflection, over the y-axis, And sometimes this is really hard to see because shapes like parabolas, if I take a parabola and I reflect it over the vertical axis, you really can't see that reflection, but it does reflect itself. It's just hard to see. It's much easier to see with non-symmetrical shapes like a cube root, for example. A cube root, if this is reflected over the x-axis, or excuse me, over the y-axis, it's very easy to see because it looks a little bit like that. And I know that's probably really, really teeny tiny on your screen, but that's what the function would probably look like. So I hope that in this video you are able to see all 4 of the different types of transformations that we've talked about in class, and you know exactly what they do. This should be helpful as you move into pre-calculus, or you're trying to take a function, you say, oh, I see something in this real world. I'm like, the arc of a football maybe looks like this. How do I write an equation that kind of matches the wideness of this arc, or that matches the height of the arc, because this is definitely has a negative number inside. I mean, it's reflected vertically. So enjoy. I hope this video was helpful, and we'll talk more in class.